Hi guys, thank you for watching. We are busy with the EL-W506 Sharp calculator. It is the advanced scientific calculator, and we're going to be looking at all the different ways you can use it in technical maths. Okay, so the calculator has 556 functions. It is right view, so that means it writes equations, or you can type in equations like you would write them in your notes or in your textbook. Okay, it does solve equations, which we'll cover today, and it integrates and it differentiates, as well as having 44 different conversions. So really nice for both technical maths and the math literacy students out there, as well as 52 different scientific constants for those students who are also doing technical science or physical science as well. Okay, so some basics. The first thing is you need to know how to turn your calculator on. So that is just the on button over here. And then underneath on is second function. And the second function just activates any of your orange functions. Then you have alpha, which is underneath second function, and that just activates any of your blue functions as well. Okay, so alpha is particularly important for statistics as well as for your memory keys. That's mainly what alpha is used for. Okay, then of course your mode button allows you to choose between the different modes, and there are 7 on this EL-W506. Then of course underneath mode is a button that says BS, and that means backspace, not what your kids write when they don't know the answer to the question. Okay, and then of course change will just change between mixed, improper, and decimal answers. And then of course equals is the answer to all piece. No, not quite, but it does give you your answer after you type in your expression, or it is used as an enter button for things like the equation solving and so on. Okay, I see there is a question, so I'm just going to check that out. Esther is asking if there's something to do with the echo. Let me see if I can fix it on my side, Esther. Otherwise, let me turn off my noise cancellation. Maybe that's better. Is that better? Otherwise, your sound is too loud. Okay, awesome. So let's move on there. Right, so modes, as I mentioned, there are 7 different modes. So the first 6 on the first screen is normal, which does fractions, integers, probability, trigonometry, and more. And then, of course, stats, which does statistics, and we'll cover single data, linear regression, and second common differences. And then, of course, your drill function, which I'm not going to look at today, but when you do get the calculator, I suggest you play with it. It is a lot of fun, and it's a great way to practice your mental maths using the calculator. Okay, and then, of course, complex numbers, which we're going to cover in depth today, matrices, which we won't cover because it's not a technical maths topic, and then, of course, a list, which we are not going to cover today either. And lastly, then equation mode, and that is just solving for various equations, linear, quadratic, and cubic. Okay, cool. So that's everything. Let's jump in. So the first thing that I want to show you is a shortcut for class marks. Okay, so I'm going to jump to my calculator now. So on your calculator, what we can do, say for example, your test is out of 40, okay, and you want to convert all of your class marks into a percentage out of 100. Oh, sorry. It's too much coffee. Okay, so what we do is we press the fraction button, and at the top, we type in where we are converting to. So we are converting to a total out of 100. Then we press our down button. At the bottom, we are converting from 40. So we type in 40. When we are done typing in that ratio, we press our right arrow button and we say times. Then we put in our first student's number. So our first student got an answer of 33 out of 40. And then we say equals, and that gives us 82.5%. And if we change that, it gives us 82.5. Okay. Here's the hard part. You have to trust me for this, okay? So your next student's mark, all you're going to do is just type in their mark and press equals. And that's it. So 62.5% or 62.5%. Then your next student gets 36, so we say 36 and equals, and voila. And that's it. So all you have to do is keep typing in mark and equals, mark and equals until your class list is done and you are happy and your coffee is still hot. Okay, so that's a really nice shortcut. And of course, it's really easy. It's available on all the Sharp calculators that function. So it's a really nice thing to teach your fellow teachers, especially during marking season. They will love you and they will bring you coffee with that. Well, at least I hope they do. Okay. Okay, the next cool thing that I want to show you is how to name your calculator. So I'm going to get back to my calculator. All right, so you can press second function and math, and that will bring up your setup function, okay? And basically, oh, sorry, your setup menu. So basically, let me just run through these very quickly for you. DRG is to choose the angular setting on your calculator, so degrees, radians, and gradients. Number 1 is FSE, which is for your fixed scientific and engineering notation. Okay, so if you are in Math Lit, you can choose fixed to 2 decimal places, and all of your answers will go to 2 decimal places, which is really nice because rounding off is not a problem anymore. Okay, the editor allows you to select between your right view editor, which is what the calculator is currently displaying, versus a line editor, which is where it's the old version of the scientific calculators where everything was written in a straight line. So your fractions had that little R. I don't know why anyone would choose that, but you know, that's that's just me. And then of course contrast is to darken or lighten your screen depending on where you are and what you need. And then of course number 5 for name is what we are getting to now. So to select and choose your name, you just choose your letters by pressing the up and down arrow keys. So I'm just going to do it short, briefly here. I don't know why I pick this every time. It takes me forever to do. And then to move across from your letters, you just use your left and right arrow keys. If you want to go change it, just select the letter and change it. Okay, so you've just got the alphabet as well as 1 to 9, and then you have a dot, a comma, and a colon, I think. So you can't type in any equations or anything like that. It's not a cheating mechanism. And then when you are done, you can see quite a lot of space. I'll show you in my slides, the next example. When you're done, you can press equals. Okay, that's the magic enter button. And when you switch off your calculator, then your name comes up. Okay, so I'll just show you again. That's the only time it's going to show up on your calculator. Okay, if you reset the calculator, of course, that name does disappear. So just be aware of that. It's not a foolproof naming rights mechanism, but it is fun to make your calculator your own, or to give encouragement. You can do this. Maybe we should get all of our matric students to write that. I'm kidding, sorry. All right, so let's go back here to the slides. So you can see I had a lot more time when I did this one. So there's the example there. Okay, I see there's another question. Oh dear, there's still an echo. I don't even know why. Let me just look at my settings quickly. Let's try this. Is this perhaps better now, guys? Is there no more echo? If there's no echo, won't you just wave at me and say, cool, we're sweet. Okay, cool. All right. So the D keys are a really nice function. So these are these keys up here, D1, D2, D3, D4, okay? And basically they allow you to choose any setting on the calculator. So they allow you to save any function on the calculator. So for example, if you are teaching trigonometry and you want to do second function and sine, then you can do this one here, okay? So you can do the long way. Otherwise, you can save second function sine into your D1 key. And then whenever you want second function sine or the inverse of sine, you would just press D1. So it's just a shorter way of typing stuff in. So if you're teaching trigonometry, you can save inverse sine, inverse cos, inverse tan into those D keys. And then later, I'll show you how to do it with the angular selection as well. So let's just type in a value here and find our answer. Okay, so that's a really nice one. Let's go back here. Okay, so the next shortcut that I want to show you is the Pythagoras one. This is really nice for teaching trigonometry. So say, for example, your P coordinate is 6 and 8. Okay, so my x is 6. I always type in my x first, and then I use my x comma y button, and then I type in 8, and I say second function 8, and that gives me my modulus, as I was told we call it in technical maths, and your angle that your modulus makes with your other radius or modulus, I believe. Okay, so that's that. We're going to do more of this in the complex numbers section as well, but this is a really nice shortcut for both pure maths and for technical maths, and you can do it on any of the Sharp scientific calculators range. Okay. Let's go back here and see what's next. Integration, how fun. Okay, so your calculator can do definite integrals. So indefinite is out, but I don't think that that's covered in the technical math syllabus anyway. So no panic stations there. So let's do an example. So your bottom, let's say we are starting at -1. Remember to use your negative button and not your minus button, or it's going to give you an error. Okay, press your up arrow key, and where we are going to, say for example 7 at the top, and then press your right arrow key to get to your expression. Now we type in, to make an x, we press RCL twice, or you can say alpha RCL, up to you, whatever makes you happy. I like shortcuts, which is why I do that. And then let's type in a exponent and add something else. Okay, so you can press equals here, or you can press right just to see that you've actually got your calculator correctly. And then we say equals, and there we go. So depending on the level of the expression, you'll see that it will be busy for longer. So typically with sine, cos, tan, it does take a little bit longer. Okay, and there of course is our answer, which is this one here. Just note that your calculator doesn't use calculus rules. It uses an approximation method, which is why you get that comma 00003. So this is a checking mechanism, and your students need to be aware that sometimes it's going to give you this tail end of a decimal because it uses the approximation as well. Okay, now we can also do differentiation, which is second function and our integral button. You'll see the ddx in orange. And then we just type in an expression. So again, we're going to use our x, and let's make it 6 minus 3. Let's leave it like that. And then we'll put it at the point where x is equal to 4. Okay, so from there, we can say equals. And again, you'll see that tail end because of the approximation method that the calculator uses. Remember, your calculator cannot do algebra for you. It can only do an actual numerical answer. So you cannot solve for x in any sense. Okay, we cannot do algebra. We'll get to that just now. There are certain things you can do, but it cannot just give you the differential without that. Okay. Okay, so here are all of your examples. Let's go to degrees, radians, and gradients. Okay, so from here, you can see on the calculator screen that your calculator is always set to degrees. Okay, if you reset the calculator, that is the default mode, it is degrees. From here, if we want to convert from 30 degrees into radians, we can do it two ways. We can do it the long way with the setup. Okay, or you can see that doesn't actually work. Sorry, what I should have done is this, and then said that. Oh, no, okay, apparently I'm just not working today. Okay, I'm going to show you the other way, which actually works. So 30, and then you're just going to press second function and DRG. You can see it makes an arrow, and then it will just convert it for you. Sure, that's a lot of degrees in radians. Let's try again. So 30 degrees, second function and DRG. There we go. Forgive me, I've only had 2 cups of coffee. Okay, and then of course, if you want to convert back from radians to degrees, you can just type in the radians that you have over 4, and you can just say second function, DRG. And then again, So you can use your D key here and save the conversion into your D1 key. So now when you want to convert from degrees to radians, you can just press your D1 button and then convert it back. So if you are doing a lot of angular movements, etc., this is a really nice short one to save. Okay, from here, the next question is, if you have 36.985 blah, blah, blah degrees, and you want to convert it into degrees, minutes, seconds, then you can say second function and DMS, and that will give us 36 degrees, 59 minutes, and 8,16 seconds. Okay, so this brings us to the time calculations, which are our next topic. Okay, so there are 4 different ways that you can use the calculator for time topics. The first is, if I have 470 minutes and I want to convert them into hours, I put a 0 in my hours placeholder, press my DMS button, put in my minutes, and then I say equals, and that gives me 7 degrees or 7 hours and 50 minutes. And then if I want to convert it into just hours or just degrees, then I can do the second function DMS and change it so that I have my different formats. Okay, you can also convert hours into minutes and seconds. So say, for example, we have 96 hours and we want to know how many minutes. We press our math button and you can see number 4 says 2 seconds and number 5 says 2 minutes. So you just select, do I want to go from hours to seconds or hours to minutes? I want minutes, so I say 5, and then it gives me my answer. So there are 5,760 minutes in 96 hours. Okay. The next type of question that you can get is the Susie train station question. So Susie gets on the train at 9:45. She gets off at 12:30. How long was she on the train for? Okay, so we're going to use our later time first, which was 12:30. So we're going to say 12 DMS 30. Then we're going to say minus 9 DMS 45. You can put in seconds here if you want, but it's up to you depending on the type of question that you're asking. I'm just going to do it as an example so you can actually see. So you don't need the seconds placeholder, just to make a note there. And then of course, if you want to again change it back into your regular hourly notation to get your fraction or your decimal answer, then it's just second function DMS and change the way it looks. Okay, so that's that one. The last type of question that you can get for time is the how long does it take me to get somewhere question. So if I'm in Joburg and I want to visit my friend in Cape Town and I'm driving because I'm a glutton for punishment, let's say it's 1,700 kilometers away, and we say divided by, and I do an average speed of 134 kilometers per hour. Don't tell my husband, okay? And then we say equals, and that will give us 12 hours and something. Then of course we can convert it back to the time notation by saying second function and DMS, and that will give us 12 hours, 41 minutes and 11,64 seconds. Okay, so that's sort of the end of the time section. Are there any questions here? Are you all happy with this part? As you can see, everything is here and set up for you. Okay, so cool. Let's, oh, I see there is a question. Give me a sec. I'm just going to read it now. Okay, awesome. Fantastic. I'm glad you're all good. Okay, so the next thing that you can do on your calculator is we actually have a random function. So to get there, second function and 7, and then you have your 4 options: rand, our dice, our coin, our int. Okay, so the rand option is just random decimals between 0 and 1 to 3 decimal places. Okay, so if you want to get your Mathlet students to practice rounding off to so many decimal places, then you can use that rand function and then just drink your coffee in peace. Okay, your R dice does numbers between 1 and 6, exactly like a dice. Our coin is a math coin. So instead of heads and tails, it will give you 0s and 1s. And then of course your R int is for random integers, and that generates numbers between 0 and 99. Okay. So let's, for example, use our dice. So we're just going to press 1, and then to roll the dice, we press equals. And there you go. So there's some nice things that you can do with your students. If you're doing theoretical probability versus relative frequency, what you can do is ask your students to generate random numbers themselves using their calculator, and then you can create a tally table. So how many got 6, how many got 5, etc., etc. And then we talk about your relative frequency. Then we do this a couple of times and we build it up and we look at what the theoretical probability is, and how, as you do more and more experiments or events, the more likely you are to get to your theoretical probability. Okay, so that's just a nice one. The other nice one is if you are in class and you're working with your students, you can ask them all to stand and to choose a number between 1 and 6, and then to show you that number on their hands with their fingers. So 1, 2, 3, 4, 5, 6. Then you roll the dice on your calculator, and whatever number you roll, those students who picked that number remain standing. Those who didn't have to sit. And then you do it over again until you run out of students. And then you can do it also with a coin. So choose a 0 or a 1. And obviously this will take you a bit longer because the probability of choosing a 0 or a 1 and getting it right is much higher than choosing the right number on your dice. And this is a really nice introduction to doing tree diagrams and multiplying along branches and adding down the branches. Okay, so that's just the various ways that you can do probability using the calculator. Cool, any questions here? Are we all still happy? Awesome. Okay, the next topic, it was requested, and it's just briefly to go through the different logs that you can do on the calculator. So of course your natural log, or log natural in French, I don't know, I'm making nonsense up. Then your log with your base 10, and then of course to make a log with any other base, you would use second function exp. Okay, so I'm just going to do a quick example with you on the calculator to show you how that works. So if I had log base 3 to the 4, then I would say second function and my exp button to make my log with the base. Type in my base, press my right arrow key and press 4. To get out of the log, I press my right arrow key again. Then I'm going to say plus, and we'll do another one with a different base. So base 4, and let's make it 12. Okay. And then you don't have to move it out. You can just press equals, but I just want you to see what it looks like, which is why I've done it that way. And then equals, and this will give you your answer here. Okay, obviously it's not going to give you a pretty answer because these are not perfect values or exponential values of the bases, which is why it gives you that decimal answer. But it is nice to show the students. Sometimes you don't always get a perfect answer. I think it's important for them because they always expect 3,5. Well, at least I did when I was in high school. Okay, cool. The next thing I want to show you is the conversions function. So we're going to go back to the calculator now. So what you can do is on your calculator, you have 44 different conversions. Okay, so if, for example, we wanted to convert from ounces to grams. So we have 23 ounces and we want to put them into grams. We're going to say second function, and you'll see here in orange it says convert on the constant button. Okay, now you can see you've got a whole menu of things. So integers to centimeters, centimeters to inches, feet to meters, so on and so forth. So you just go look for what you're actually looking for, and for us it is ounces to grams. So we say 13 because that's the conversion rate that we want, and then we say equals. So we have 652 grams. 23 ounces is 652 grams. Really nice and easy, not complicated at all. Now, we also spoke about the constants, which you have 52 of. So don't ask me what these constants are. This is all science, which is like Greek to me. And it gives you the units that it is in. So if I wanted the alpha exponent, the alpha constant, I would just type in 15. and then you'll see that it actually types the whole thing into the calculator for you for your calculation. Okay, so it's just a shortcut. Instead of having to type in that long expression, you can just use that constant. So if you are a science teacher, you should definitely make yourself familiar with what constants you would actually require on the calculator. Okay. The other thing is we can do binary conversions, which is really nice. So if, for example, I have 56 and I want to know what that looks like in binary, I would just say second function and my divide button, and that will give, you'll see in orange there, it says to binary. Okay, so let me just go through these. Hex is for hexadecimal numbers. So if you're doing programming, that's a nice one to know, particularly color selection. Then of course, binary, decimal notation, which is what we always use, or most of the time, and then octadecimal and pentadecimal number bases. Okay, so those are just your selections. Now, if you have binary, you can type in any binary number that you want. You'll see if I try and press my other number buttons that it doesn't work, okay, because you are in binary. Let's add two binary numbers together. Okay, when you're done, there is your answer. If we want to see what it looks like as a decimal answer, then we can just say second function and plus to give us decimals, and that answer is 274. Okay. Any questions here? We're all still happy, feeling good, you're still awake. You didn't spit out your coffee and say, oh my goodness, that's ridiculous. Okay, good stuff. All right, let's do statistics now. So before I go back to the calculator, let's just chat through your stats menu. So you have SD, which is for single data. Mary's maths marks are. Then of course, line for linear regression, which is A plus BX. And quad, which I'll show you as well, is for second common differences. So we'll find the equation for your second common differences pattern as well. Okay, it's really nice. The rest of the modes, don't worry about. We don't use them in high school level. Okay, so to get to our stats mode, we press mode 1 for stats, and then we choose 0 for single data. Okay, now you're going to just type in your data. So you're going to say 89 and change, and then you'll see it says that's your first position, and then 74 change, 52 change, 98 change. I'm making up nonsense here. 63 change. If you want to type in something with a frequency, just use the X, Y button up here, and then say my frequency is 2 and change. When I'm done typing in my data, you'll see you can go back up and check what's what. And then of course, every piece of data has a frequency. Okay. Now we can find the average by pressing alpha and 4 and equals, and that gives us 78. If I want my standard deviation, alpha 6 and equals, and there we go. If I want to know how many observations I had to check that I've typed in the right amount of data, then it's just alpha and my 0 button. So you can see everything here is a statistics thing in green. So you just press your alpha key and whatever you are looking for, the sum of x and equals, and there you go. Okay, let's go on to linear regression. So we're going to press mode 1 for stat and 1 for line. Okay, now for linear regression, it's a scatter point graph. So you need to type it in as a coordinate pair. So your x and your y value together. So we do that exactly the same way as we did it with the frequency using our x, y button. And let's call the first value that. I'm making these up. So let's hope my line works. And let's not make a perfect line. Okay. So you can put in as many as you like. There's space for 100. I've never seen a question with 100 data points because it would take us 3 hours just to enter the data. When you are done, again, you can find all of your statistics still using those menu buttons on the left. If you want your line, above your open bracket is A, above your closed bracket is B, your correlation coefficient is on the divide key. So if I wanted my y-intercept, which is A, I would just press alpha and open bracket and equals, and we can see it's 1/3. Okay. If I want my gradients, That's my close bracket, so alpha close bracket and equals, and the gradient is 4.5. Okay. If I want the correlation coefficient, it's alpha and the divide button and equals, and then you can see it's almost a perfectly straight line, but not quite. So strong positive correlation here on the calculator. Okay, so that's pretty much how the linear regression works. Let me show you the quadratic one. So for your patterns, how the quad works is your x is your term position and your y is your term value. So x would be 1, 2, 3, however many positions you have, and y would be whatever the pattern is. So if our pattern is 1, 3, 7, and 13, I hope this works. We're going to do that and change. Then number 2 was 3 and change. Number 3 was 7 and change, and number 4 was 13 and change. Okay, so there's all of your coordinate pairs. You can see that they all belong together, and you can go back up and check your data as well. So again, to find your line, remember that we're using a statistics quadratic equation, so it is a plus bx plus cx squared. When we do solving equations, it will be ax squared plus bx plus c, but we'll get there. Don't stress. Okay, so again, to find our x squared coefficient, alpha and our times button and equals, so that's x squared. Then let's find our x coefficient. My pattern worked. Minus x, and then let's find our y-intercept. It's 1, so our pattern is x squared minus x plus 1. Now, what's really nice here, and you can use this in the linear regression as well, is to predict your values. So for example, if I'm given that x is 12 and I want to know what my y value would be at x is 12, I'm looking for y. So I press second function, and you'll see above your close bracket button is a y with the apostrophe, and that tells me that when x is 12, my expected y value would be 133. Now we can also reverse that. So say for example, our y value is 36, and we want to see whether or not it is actually a term in the pattern. So then we would say second function and our x prime value, and we can see it's not actually part of the pattern because it doesn't have a perfect x. So if it was part of the pattern, you would get a definite a whole number answer here. Okay, and we always know that we ignore the negatives because patterns don't have negative number answers. Okay, happy here? That's the end of stats. Oh my goodness, I'm so silly. Sorry. That is me being a dwarf. Give me a seckie. Okay, I've done something very stupid. Apologies, guys. Anyway, let's go back here. And I'll find my calculator just now. I'll have to figure it out in a little bit. Okay, so that's all of the stats questions. Are there any questions with regards to stats? Are we all comfortable? It's not too complicated. Okay, so everything is here for you. You can go and practice the questions and see if you get it right. Awesome. Thanks, Teresa. It's nice to know people are still out there and awake when you reply. Okay, I'm going to have to do this the long way around. Apologies. Sorry, give me a second, because when I do blonde things, I do them properly blondly. And I would, of course, put my calculator in 40 different. Okay, all right, we can go back. I should just have stayed blonde, really. Okay, so let's talk about complex numbers. So on your complex mode, here we go. I'm going back to my calculator here. So to get to mode, the complex mode, just mode and 3. And then what we're going to do is you can see on your left hand side it's in your XY. So in other words, it's in your rectangular coordinates. If I want to change it into my polar coordinates, then I just say second function 8, and you'll see it changes your standard answer. So if, for example, I had 8 plus 3, and I want to put in an I, that's this button here, and I say equals, it will give it back to me in my polar coordinates. If I make my setup rectangular, then you can see that it gives it back as rectangular, and it gives it back to you as real and imaginary. What I can then do is also convert from from rectangular coordinates. I can also convert from polar coordinates to, let's make a negative angle, because we were asked yesterday, I couldn't tell you. So, and then that will give it back to you in rectangular coordinates. So you can convert very easily between the two just by changing your settings. You can also, apologies, just press math, and you can find your conjugate, which is 1. And so we just open a bracket like so, and equals, and that will give us the conjugate value of our complex number. Sorry, so just again, to make an I, it's the integral button, and then to type in your modulus and then your angle, it's this button over here, your DMS button. So DMS doesn't work in complex mode, it just gives you the angle separator. Okay, so that's your two values, or two ways that you can do complex numbers. That's pretty much all there is to complex numbers on the calculator. So yeah, does anyone have any questions? Are we all still good? All of it's all done here again, so you can again go and look and see if you have any questions. All right, the last section we're going to cover today is the equation solving section. So to get there, we press mode, and that's our last option, which is 6. And then you have this menu. So 2 and 3 variable linear equations are linear equations, which means that your x and y cannot have any exponential values. So it will just be x. So ax plus by plus c. And then your 3 variable would be ax plus by plus c, z plus d. Okay. And then, of course, your quadratic equation is ax squared plus bx plus c, and your cubic would be ax cubed plus bx squared plus cx plus d. Okay, so if we did the quadratic equation, for example, you can see here's your a, b, and c, and we just type in those values. So I'm going to just do a very basic example with you. So a is 1, press equals, make your b value -5. Remember to use your negative button and not your minus button, and equals, and 6. I hope that works, and equals, okay, and there you go. Your x is 3 and your second x is 2. So your intercepts on your graph are 3 and 2. Okay, and that's pretty much it. If you want to go back and do another one, you just press your on button, and then you can just type over the values. Making up nonsense. Here you can see that it is actually not a possible answer. So that one doesn't actually go through the y-axis. Okay. Sorry, the x-axis. All right, so that's pretty much how equations boil down to. Let's just do a cubic one just for fun. Okay, so again, we can just say, I'm making up nonsense here. There you go. So those are all of your x-intercepts for your cubic graph as well. And again, if you just want to go back and do another one, just press on and just write over whatever values you have. Nice, because you can see what happens if you adjust one value as well. Okay, so that's equations, and that's pretty much everything that I wanted to cover today. I've done it even faster than I did before. I feel like I've left something out, but anyway. So just so, let me pause here. Let me pause the recording.